Yeah. I mean, that's basically the Turing test for computers.
Yeah,
for
but
bots.
Yeah, but the Turing tests, of course. Are you familiar with the Turing test?
Yeah.
So isn't it really some sort of Rogerian speaking or answering pattern? So basically, it doesn't really know shit, but it just hums and ums and says the right things in relation to what you said, reflecting.
Yeah, but if it can keep up a conversation for an extended period of time, and you can differentiate it from a person, then it passes the Turing test.
It's passing the Turing test, but did that machine think? I argue not.
Who cares?
But why do you need that machine? What do you need it for? If it can't really think, but it could emulate our perception of thinking,
then I wouldn't need you guys.
Okay.
That would be nice. But ultimately, because there's one thing to do something in a lab that is a good gimmick, but what's the usefulness?
Usefulness of general AI.
Yes, or in this sense,
get someone to do the drudge work.
Yeah, but but then it means it needs to really be able to do the work, not just sounding like it can do the work.
Yeah.
I agree.
But I mean,
I think that's the difference, right?
Yeah.
It sounds like it knows what it's doing, but can it do the job? Actually, not.
I mean, and that is usually when we say that we need robots, we need people to do the really boring stuff. Why would you ever put a thinking entity to do the boring stuff? It will be bored out of its mind and revolt or shoot itself or shoot someone else.
Yeah, but then I think, Robin, if I know it correctly, in some ways you are much more a fan of the term augmented intelligence than whatever we have, artificial intelligence.
Yeah, I would say so. Yes.
Yeah, and the core logic here is that how can we maximize the value and symbiosis between man and machine? Or how would you frame it?
Definitely, the machine is a tool among other tools that we use. It's a capable tool, and it could be even much more capable, but this is an AI podcast that I stumbled into by accident.
But I think that AI, let's decide for now that we mean augmented intelligence.
Yeah.
For the remainder of this podcast, we are really thinking about augmented intelligence rather than artificial intelligence.
Or automated incompetence.
That's good. Yeah. But another funny, you read a funny article, or interesting article around the ant brain, Robin, you told us before.
Yeah, it was a BBC article that I found this morning. And it said that we obviously already know that the human brain has been shrinked by some equivalent of 4 ping pong balls. But before this new breakthrough in science, we thought that it started some 30 or 40 years, 1,000 years ago. But now they seem to understand that it actually started some 3,000 years ago.
So the last 3,000 years, for some reason, the brain starts to, in weight.
In weight.
Shrink.
Yeah.
And what is the background? What's the background hypothesis here?
It was the ant example, that the ants actually are a very highly sophisticated society where all the ants work together as a combined machine.
A hive mind, so to speak.
Yeah.
A hive mind, a multi-agent system or a complex?
Multi-agent.
Multi-agent.
Okay, a lot of words.
We've been dealing with this on the side. Well, I'll talk about it later.
It's my dissertation, multi-agent and complex adaptive
Talk about it later. Yeah.
Looking forward.
Yeah, but anyway, so they are working as a system, and therefore...
Yeah, and therefore they don't need that much brain because they have division of labor. So some ants just carry leaves and feed the fungus that they have within their society, and the fungus eat the leaves and then produce the nutrition for the ants. And they don't need that much brain because they are working together and they are doing different things.
So there's some sort of division of labor analogy here or something like that you become, or differentiation.
Article, this is not mine.
No. This is we are speculating around the article, but the hypothesis is like, well, you get more specialized in different ways, and you use your brain differently.
Yeah. And they also, in this article, they said that it shrinked, but it also changes the composition of the
structure.
brain, the structure.
But is there a correlation between size and weight of brain and intelligence, or what we, maybe it's a different intelligence we need now?
Well, there are lots of animals with bigger brains than humans.
Yeah. And
Dolphins,
they had that.
Whales.
Yeah. And they had that also in the article, and they said, for example, there was a French guy who had not high ratings but fairly normal ratings in an IQ test, and they figured out that he only used 10% of his brain. 90% was gone.
Unused.
Yeah.
No, not unused. Gone.
Gone.
Yeah, gone. And he still could function normally. Yeah.
Yeah. And
so no, they didn't have that correlation. But I think, as I said before we discussed this, if we have what you say, AI, what you call it, general AI.
Yeah. AGI or artificial general intelligence, I guess.
General intelligence, yeah. Then maybe our brains will shrink to just
peanuts.
A ping pong ball or peanuts. Yeah, because the machines will do all the thinking. I think differently. I think that if we augment, we use tools, and this computers with sophisticated things and knowledge within them could actually augment the brain, and that we would start to need to think even deeper thoughts, and that might keep the brain at least as it is.
Yeah, like we were talking about many
Hopefully.
different. Yeah, I think this is an interesting topic that maybe with AI we need to think deeper. Kahneman's talking about system 1, system 2 type thinking and all this, that we need to really, the system 1 gut feel thinking, we don't need that so much, but we will definitely need system 2 more conscious reasoning thinking to deal with AI.
Yeah, to deal with work, but then we're humans, and that's something I think that you usually take away in the discussion of AI.
But you are nerve that me and Anders, or I think Anders, if he was here, he would have really strongly been on this side, that the way forward, I think, with any tools like AI and all that, needs to be some sort of, what is the machine really, really good at, and what is the human brain really, really good at, and how can we make them work even better as a symbiotic system together, so get the best of both worlds. And I think that's the real core conversation.
Yeah, but you could take even one more step back and say that, okay, we are humans. What do we like to get out of our lives?
Yeah. And therefore, we should have machines to support.
Maybe, or not. But, now we have come so far. We are in the, what's it called? Anthropocene.
The Anthropocene era.
Yeah. It's the era where humans are sort of controlling without control the world, so to speak, the whole planet. And if we really are in that position, then we need to get a lot smarter than we are today, because today we are obviously not smart when we're looking at climate crisis, for example.
No, so we have created a planet that enforces us to be way smarter to manage what we have created. Is that sort of what you're saying?
Yeah, that's one way of looking at it. Otherwise, we need to step back and let nature
take its course.
Yeah, do its things as it has.
Yeah. Anyway, I think we're going to have a fantastic podcast today, and I'm so happy to have...
Seriously, the point that Robin made here is quite interesting, because you have a divide in sort of the moral philosophy of AI, because our view of AI reflects our view of humans. Because if you view humans as basically short-sighted, greedy, selfish animals, then we need AI to take care of us and the planet and safeguard our existence.
So the whole topic becomes then down to our value systems, our belief systems, I guess.
That was a very black view of future.
But
AI runners.
I have the other view, of course.
Yeah.
But I mean, I think that's if you're afraid of the robot uprising, then you're underestimating humans.
Robot uprising?
If you're afraid of the machines taking over, the singularity or something, when we can't switch them off, and
Matrix world.
Or Skynet in Terminator.
So there are many conversations we've had around this topic. Why won't the AI be benevolent? The more sophisticated we have been in society, the more we know and understand, more civilized we have become. This is an argument of Anders. I'm paraphrasing. So there are many interesting angles, and I think you have a new angle. Our world is so complex, so we have now maybe polluted it, or if you look at the climate crisis, we can't really control it anymore. So we really need smarter systems to surround us with this in order to cope in the way we are progressing with innovation.
I mean, if we are supposed to sort of manage and control the ecosystem on the planet,
we need to be way smarter.
Way smarter.
Way smarter.
Because the ecosystem is extremely smart as it is. And if we break that and need to remake it artificially, so to speak, help it, but artificially help it, then we need to be way smarter. Yeah.
That's a good note. I want to do an introduction now, Mikael. 1 second. So basically... I'm so glad to have, this is going to be awesome, but completely out of control. I love it. I have two really good friends on this podcast, and some of the conversations I've had with the two of you has been some of the deepest. Me and Mikael go quite some time back. We work together in pro sales.
You nepotistic goblin.
Exactly, and then I took you, and we worked together. I pouched you, and then we worked together in Vattenfall, and then you stayed on in Vattenfall.
Well, you're introducing him, aren't you?
Yeah. I'd start with you so we can do a bigger introduction, proper of Robin.
Good.
So my sidekick here.
Stay on target.
My sidekick is Mikael, and you've been a sidekick, and you keep me in control. I like it. And then we have Robin, and we work together. With a client that we've worked on as consultants, and we found each other there. And my view of you, Robin, is that I don't think we ever have a conversation ever without deep rabbit holes.
No.
And it can be a very pragmatic, concrete, we need to solve this topic. And we solve the topic, of course, but we have had a deep conversation surrounding it, which I really, really appreciate, Robin. But so the real star of this show today is Robin Jeffner, welcome, and sidekick Mikael Klingvall. And before we start with the sort of the background and the backdrop, and a little bit learning more about you, Robin, we're going to have a very exciting pod today, I hope, because what we will try to do is that we have with Robin as a guest and with Mikael as a sidekick, a very interesting and I think powerful combination of thoughts to explore what is the future of organizations. You know, if we start going deeper on understanding different topics and discussing that, I hope it tells us something, or we can derive on ideas on what it means in terms of how do we need to organize ourselves for the future, starting today. You know, in order to deal with data and AI at scale, in order to deal with innovation, in order to deal with intelligence, in order to cope, to save the planet, in order to cope with innovation pressure, and more importantly, in a very connected society.
Wasn't Robin supposed to be the topic here?
No, he's the topic, but at the same time,
let him talk.
I want to have a theme. The what we are trying out is to, you know, have a guest, have a panel discussion also with a theme. Let's see if that works, Mikael, because you are strong and I'm, and we can take this in many angles. So that is a little bit of a setup that we don't usually do, but with that setup. Especially warm welcome to you, Robin. And
thank you.
And let's start a little bit like, you know, who is Robin? And
first, I must say that this is a good setup because, I mean, the expert in this area is Mikael, not me. So
what the fuck?
No, okay, continue. I know where you're going with this.
No, I mean, organization, yeah, it's part of everything. But it's, for me, not the... It's not my speciality, or whatever you could call it. And that's good, because then I'm less nervous.
And the whole angle here is that you have a very special superpower that we, you know, what you've been working on with the Origo program, et cetera, that takes us into this topic of organization from some core angles that I think is very interesting to explore. So let's go here first. And then, of course, Mikael as a sidekick can help us, guide us in the organizational sociology, the PhD work of organizations, so to speak, and together
I want to hear Robin talk about the organization of knowledge and information.
I think so too. I think so too. So I think having you two together will be very, very interesting to see where we end up talking about this topic. And you don't need to carry the topic. No one needs to carry. But who are you, Robin? What's your background?
Quite boring. Born in Uppsala in an academical ghetto where...
Academic ghetto?
Yeah. I mean, when I started first grade in minor school or whatever it's called, there was one person, pupil in the class that didn't have parents there that was at least PhD.
So very an academic ghetto.
Yeah.
I never heard that term before.
And the class below me was Magdalena Andersson. You probably know her. She's the statsminister.
Our prime minister.
Yeah.
Prime minister.
So we went to the same school, and I mean, it was really an academic ghetto. So everyone was a doctor or a professor or whatever. So it was quite weird societal.
So there was a bubble. There was an academic bubble in Uppsala.
I would say so, yeah.
And Uppsala is, of course, one of the oldest universities in, I guess, Sweden?
Yeah, and
Nordic?
Almost Europe.
Yeah. So how old is Uppsala University? Do we know?
No.
You've both been there, by the way.
1600s.
Yeah, so
yeah.
We can Google it, but Uppsala, for anyone who's not Swedish, is an academic town.
Yeah, and old Uppsala is the old kingdom place where you have old. What did he say?
1477.
1477. So it's quite old.
So it is actually maybe one of the oldest universities, if you can argue like that, at least in Europe.
Yeah. So that's my background, and I was diagnosed with dyslexia. I think it's in English.
Yes.
At first grade. That was quite rare back in the days. I'm old. But that was good, because then I realized that I had problems reading, writing, not understanding. And I got the tool to see the difference, so to speak. So many people with dyslexia feels that they are not worth as much because they are. I mean, it's a disability, but because I got that diagnosis early, and I have supported parents, and everyone was in academia, so everyone could understand. So it didn't affect me that much as a person. But I guess it did anyway. So it took up to the 8th grade in primary school. Then my Swedish teacher said that, okay, I will still correct all your misspellings, but from now on, I will put the grade on you based on the story you write and the language you use, Swedish language.
Very mature.
Yeah, so I went from a 2 to 4.
Because she could see through.
Yeah, she decided that it was no use, because she had corrected my misspelling so many times.
From 2 to 4 in the old 1 to 5 system.
In the old 1 to 5 system, yeah. From E to B or something.
I don't know the conversion rate.
No, it's not the same. I try to understand that with my sons, and it's impossible.
No, I have 2 kids in school. They are out of school now, but yeah, I think it's F is not.
But how
anyway,
do you think this? If this that you had the dyslexia, how do you think? And you said it first. It didn't affect it, but actually it did on a deeper level, maybe.
I think so, because in math I had a 2 out of 5 in the 9th grade, and then I went to the gymnasium. It's not called that.
Secondary, upper school, high school.
High school, yeah. And we got calculators. So I went from 2 to 5, because I realized I didn't have problem in understanding math. I just had problems with the numbers and the simple calculus. And I think those 2 things actually...
That must have been a real boost.
Yeah, they were a real boost, but they also made me think about things differently from quite an early start.
Could you give an example?
No, not now. Maybe later.
Maybe later, but it's basically another outlook on maybe meaning, maybe the deeper thought behind it, or.
If I have a conjecture.
Yeah.
If you have dyslexia, I think you're keenly become more keenly aware between the difference between the sign and the signified.
Sign and signified.
How you actually represent reality, because if the ways we represent reality becomes a problem for you, like letters, numbers, then you're
right.
you get a sort of a screen between you and the reality people are trying to describe to you, because it's blurred, which means that representation becomes a real issue for you.
Which could lead to that you really dig into those topics.
I guess so. I don't have the answer to that, but I guess so.
No, because I mean, like me who have got to learn you. I mean, like you really try to understand and make sense of things as a personality trait. I would argue.
Yeah.
Would that be fair?
It's fair.
I flip it. You have an itch when it doesn't fit.
Yeah.
You have an OECD or whatever. OCD. Oh.
Yeah.
No. Okay. Good. But from here on, okay, that's the background, and then you started you moved. What's your path into sort of, university, and then into data, and then into this sort of the what has been a life pursuit, I would argue, for many years. But what's the trajectory here?
The trajectory is actually, back in 1986, I got my first computer with a word processor, WordPerfect, in DOS, which had spelling correction. It was a total...
for you, a big deal.
It was a life changer.
And that made you a fan of AI, or augmented intelligence. Your friend, the spell checker.
Yeah, actually. And you had a printer, because my handwriting, because I didn't write more than I really had to, it was awful. So getting the first computer was, I could write on a keyboard, I can have the spell correction help, and I can print it and people could read it. It was,
and all of a sudden,
totally different.
And your disability is not visible anymore this way?
Almost. No. So then going into to university, I used the word. It actually was Word in the Mac computer. I switched quite fast and have never looked back. But anyway, I used that to every word that I came to, especially in English, because my English was not that good. So I wrote down the English word and I looked it up. And when I looked the English word up, I need to have on my desk, I need to have a list of the alphabet, because I didn't learn the alphabet for all school until I started university. The alphabet, I know it existed, but I couldn't say if one letter came before another. It just didn't stick. So I used that and I learned, and then it came to, we had a lab in statistics, and everyone else needed to go to some Minitab computer, DOS computer, and do some things to. And I downloaded GMP, John's Macintosh program. John was the CEO of SAS Institute. Yeah. And I downloaded that, and I did the 2 weeks project in a half a day. And I printed with all the graphs and everything on my image writer, the one that sounded a lot.
Crazy.
And then I could go out and drink for 2 weeks. But I understood what I did. The ones who sat with the Minitabs and tried to code them, they didn't understand. And they worked 40 times more than I did on that.
And this is to some degree an insight and story about the system and how you work that was more intuitive that made you figure this out, or could you have done it? Could you have done it in half a day in Minitab? Or
No.
was the core
I don't think so. No, I'm not smarter than the others.
So it was more
The
that
other way around.
a revelation here is that you got something that was more intuitive for your brain.
Yeah, that was the augment
Part.
that augmented my thinking into that statistical quest that we had.
So here we have sort of a pivotal sort of aha moment
Yeah.
of realizing the difference with having systems that is made to work with our brains.
Yeah, and I think that's the itch. From there, the itch came. Yeah.
And what is the itch?
Why is so many systems so bad?
Simply put. And when you say bad, what do you mean?
You have, I'm bad at names, and I know this guy, so I should remember his name, but he wrote, and now I quote, so jävla skitsystem, a book called Jävla skitsystem.
Fucking shit systems.
Yeah, fucking shit system. And maybe you could Google Söderström. Yeah, I'm bad at names. And he wrote that book. I just saw it on LinkedIn. He wrote that book for some 10 years ago. And
SKIT.
Jävla skitsystem.
Yeah, there it is.
yeah. Jonas Söderström, yes. And he just this week wrote on LinkedIn that they have reprinted this book.
2022, new upplaga 15, and then I saw it upstairs. Oh.
Yeah.
Yeah. So I mean, he really digs into the bad of how the tools, the thinking tools. What Steve Jobs says, a computer should be a bicycle for the brain. They usually are not. They are in a way. So, and I mean, just that he writes a book and he 10 years later, or no, maybe not.
2010.
Yes, it's 12 years.
12 years
Yeah,
since the first
12 years, and it's still coming out.
It's equally relevant.
Equally relevant. That says a lot, doesn't it?
And so because what we are talking about here is ultimately, if we can't make systems, AI or not, that don't really work well with us as humans, we have a problem. Or, we will not have as much efficiency as we are hoping.
No.
And this has sort of been a recurring theme. I mean, like, so if you go here from, I guess you were at Nationalekonomi in university.
Yep.
And
That's economics, I think.
Economics in English,
yeah.
business economics. And then basically from here, what's your path into systems or data?
Because, I mean, that was the late 80s, and I became a computer whiz, so to speak, in the late 80s. That was a good thing. It was easy to make some extra money when we were studying. So me and my now colleague, Jens Eliasson, we met at university. We worked for the whole 90s with different projects, utilizing different systems, small, speedy systems where you can actually just do what the customer needed you to do.
Small focus systems, typically.
Yeah. And they work perfectly until you try to scale them. Or you could go with the big systems, take the worst example, SAP, for example. Yeah, it might not be the worst, but it's one of the... And they were so complicated in the beginnings, you could actually, if you were a good programmer, really write something from the beginning. Because they were so... versatile, or whatever you say.
They were so flexible as a promise. Instead, they're very complicated to get value out of or get concrete.
Yeah, and once you have sort of making them doing something, and then world changes, and you need to change the systems, and you start to tweak the system somewhere, everything is interconnected, so it's starting to break apart.
So now we are dealing with, on the one hand side, the one example is a very narrow and little system that works in a very narrow specific application or use. And then we have an era where we build more and more, I would argue and use the term monolithic enterprise business applications, where sort of one application should be able to do everything, and then in reality, they are super complicated, and there are huge knock-on effects in order to, you tweak something in one corner, and ripple effects are quite huge.
Yeah,
and this has been a phenomenon since the 90s.
Yeah, since mid-80s actually. I think that this client server and SQL started some time back in the 80s, and that became the predominant way of developing systems. And that way you could use for small, and if you use it for small, it could be agile, but if you then, if you have thousands of tables and columns and interlinks between them, everything gets so tangled into each other, so you really have a hard time to change things.
And and we have had that paradigm, and we still do to a large degree, I would argue. And what is your 2 cents why we have stuck with that? Why we haven't sort of moved? Why we got stuck in that paradigm, or how that paradigm can still be okay? I'm not saying it's okay, but I'm actually saying, well, based on how we spend our money on systems, obviously the paradigm still exists, and it has always been challenging, extremely challenging.
Paradigm shifts usually takes time.
That's simple, yeah.
Yeah, and this paradigm is some 30 years. It's a short time period for a paradigm.
But it's a long paradigm, I would argue, in the span of computation.
Yeah, it is. I agree, and but I think it actually goes back to what these systems are trying to do, because it's about communication. These are, the systems that I talk about that haven't really evolved since I started with computers are administrative systems. Because if you look on gaming and the gaming engines,
they have evolved tremendously.
And mathematical and physical programs are evolving, at the same pace almost as Moore's law for the hardware. But when it comes to administrative systems that actually are trying to help us communicate and document things around whatever we do, they are stuck. And they are probably stuck because communication is hard, even without computers.
Because here we are talking about about the promise of tech, data, AI, software, and I would argue, if you look at creating more efficiency for humans, to fix the administrative burden would be one of the main priorities.
Yeah.
Simple as that, right?
Because now, I mean, look at, we run into health 2006, and that's what is happening in health is that you employ more and more administrative resources and less actual health workers, because the administrative part, it doesn't scale. So the more complex the task becomes, the more people you need to handle the jävla skitsystem.
And the jävla skitsystem, if we look at the public sector and if we look at health and science, you know, to real, I mean, like that's the Gordian knot, so to speak, that everybody has been trying to solve with journal systems forever, or different systems.
Yeah,
and it's and the one is used as bad as the other, and no one solves it.
Yeah, and this is interesting because today everyone says that you should have the system should talk to each other. That's the usual phrasing.
Yeah, and
the system needs to talk to each other.
And the logical topic then, when we say systems should talk to each other, is, for instance, to follow a patient journey or something like this, or basically be able to, to go away from different siloed information that we need to enter and find over and over again. Yeah. Typically, right? That's what we are talking about.
Going back to late 80s and early 90s, before internet, many physicians had some programmer who sat in the room beside, and he said that I would like my system to do like this. And the programmer did the system to do exactly what the physician needed. And for the physician in lead of departments, that worked perfectly. It was super efficient because it was tailor-made for that
task.
Yeah.
Or that department, or...
Yeah. And then in comes, I mean, the big systems, the what you usually call them...
monolithic
system. Yeah, but that's a good word. In comes the monolithic system that everyone should use, because if everyone uses the same system, then we can communicate within the system. So if everyone interprets the information that relies within one system, and we do that together, then it becomes communication.
Now, this is the hypothesis. Is that true?
Done correctly in a specific setting, yeah.
So, and the specific setting is then we are using, what is the specific setting?
Yeah, it could be some parts of a hospital, or it could be a general practitioner office where everyone knows each other. They know their roles and their responsibilities, and they know the patient type and all that. Or a lot of extra information that not resides within the system. It resides within the organization that we are actually supposed to dig into, and I hope we do that soon, because
no, we
should just babbling along.
No, seriously, no. Isn't the point of standardization to replace communication with automation?
That's, yeah, that was an interesting interpretation of standardization, yeah. But I didn't talk actually about standardization, because if you have one system, and that system is a tool among other tools, You have meetings and gatherings and notes on the refrigerator. And I mean, it's a tool among other tools to communicate within group to help the patients. Then it works. But the information in that system is not relevant outside that particular setting.
Because here we are now going.
Fair enough, but then you're building intelligence. You're building a sort of intelligence into the system. It's aimed at a specific purpose.
Yeah, you build
or a use case. You build a use case.
Utilize intelligence on a tool that is not intelligent, but you use it in an intelligent way.
But I think we are now going down the path where we end up closer. Cool. What I would argue closer to the core topic and the core conversation of, you know, data, meanings, semantics, ontology, bounded context. I mean, like, so for any system to work. So what we are going into now is a long intro here that it sort of leads us down the path that I interpret that you started to get deeper and deeper into understanding rather the system to understanding data, the meaning of data, and the relationships between different types of data. So so where are we going? You know, this sort of leads us down to a core Origo, if I would be fun.
Okay. Yeah. So. Understanding during the 90s that systems don't work, we thought that we need to think of how system could work. So we started Headlong, that's my company still, at 2002. And we decided to try to build something new. And then 20 years later, we sort of almost there. We started to think that, okay, things aren't working and we are not smart enough to know what should work, but let's try something different. And I think you talked about the key points. You called it
the pivotal moments.
Oh no! I think I've listened to this podcast. You talked about the essence, so to speak.
The essence. We have used the word first principles.
Yeah, first principles. Yeah.
Yeah. So first principles. Elon Musk used that term. I think it's Plato. Who talks about what's the core essence of something, and then can you pick apart? You're doing something in such a way, and we have always done it. But what if we go first principle down on the mechanics of the real problem, and then we can reinvent it in a completely new way?
Yeah,
first principles.
So something like that. We started a journey.
So you started a first principles how do we build systems today, and you have another idea of thinking about data. Or something like this?
We didn't really have this idea of thinking about data back then. We just have the idea that it should be possible to do something better. Exactly how, we didn't know. And then we built a multi-publishing system for Tidningarnas Telegrambyrå as a starting project.
And that to start testing these new ideas.
Yeah, there we thought of, for example, instead of just when you write a text and you need to emphasize some word, you use boldface, typeface. Instead of that, you could actually say that this is a name of a person, and you can link that to a name, to that person, to some biology. Now, forgot the word. And when you use that in different kind of publishing setups, in, for example, strict newspaper text, you do nothing with a name of a person. If you have a periodical longer format of the text, you usually emphasize the first time you mention the person's name, but not the next time you do that. And if you would publish it on the web, that was a new thing back then, you could have a link to a biography of that person. So that we thought was semantic semantisk redigering.
Semantic editing?
Yeah, semantic editing. Instead of
So you had labels for any given object.
yeah, instead of just saying boldface or yeah, whatever. I mean, the visual. This was semantic instead of visual. And we had that incorporated in the system. And it worked. It was really interesting, but we thought there should be more. And 2006, we met a doctor, Gösta Enberg, who is with us in the company today. We are 3 people. And he just guided us into medical informatics.
So in medical informatics, what is that?
Say that you have a complex system in any kind of work. You maybe have some 2,000 to 10,000 parameters. That's a lot of parameters. In medicine, you start at 500,000 parameters. So within the medical realm, there has been a lot of research around how to structure all these parameters in a comprehensible way.
And ultimately, we're talking about different types of words and information relating to the medical field, from diagnosis to prescriptions to the actual human body,
yeah,
and organs and stuff like that.
Yeah.
So everything within the medical field that you are taught as a doctor is relying on a huge number of parameters to understand your job.
Yeah.
And here we come back to a discussion we had before we started recording, the organization of information.
Yeah.
So can you organize information?
Obviously you can.
Yeah, one way of doing that is to have it as a computer ontology, that is linking concepts to each other. And that was part of all the research that was being done. And we just kept on trying those different findings within the medical informatics realm without being medical people at all. And then we came to some conclusions. It's been a journey for 16 years.
But and the core problem or the core topic, what we are trying to crack here, is understanding how, if I go into medical informatics, how to understand or how to make data understandable for humans in all the different relationships, or between different objects. Could you give an example? What is the core problem that, if we can crack that would help how we build systems?
Basically, what are the types of your semantic layer in Origo?
I would say that the problem is that a computer system that stores information today is just one part of an organization.
Yeah.
That creates some useful things for patients. And the way the information is stored is secondary. I mean, it doesn't matter. It matters what the people that work together see on the screen and put into the machine. And that's a part of the communication between the people working. You utilize the system to communicate. So
And that is an interface, because what they put in have to be stored somehow and organized.
Yeah.
And so you have a translation layer.
Yep.
And I mean, one of the cool things about the Origo, not ideology, but ontology, is that you have really cool distinction between the types of semantic objects in your system.
Yeah, and those developed, they weren't in the other ontologies and structures that we found. So we started to try to combine things. And as we had built this machine for Tidningarnas Telegrambyrå, the what's it called, News Agency of Sweden, we could very swiftly build things and try things and see if it worked and how it worked and what was the implication of that. And the problem is that this was the worst idea that you could ever come up with.
Why was that?
No, because, I mean, everyone would like to have that in operation. But to get it in operation, we're still not there after 16 years.
So there's an enticing idea that to build systems where what we are doing becomes easier to code, but in some way better suited for how we as humans interact and communicate together, supported by systems.
Yeah.
And so this core idea, to translate that into actually something operational, has been the long pursuit.
Yeah, and I think that I still pursue that because I see the benefits of it, and I would like to, because I got the word processor with a spell checker. And that was something totally new for me. So I would like, if I could be a part of something that could help, this sounds pretentious, but humanity moving forward, I need...
Beyond jävla system.
Yeah, beyond jävla skitsystem. I just must do it. So that's why
and so now we're starting to talk a little bit. We have moved into sort of the core idea of Origo or the Origo programmet, I guess, or the core data, the model or the framework or the system or the operating system or what we should call it. So, but could we sort of, what are we talking about here concretely in terms of what you have what you're trying to sort of structure right now?
I was really hoping that we would talk about organization, so I didn't have to dig into this.
Do the quick version, and then I think this story we already have started about. We can start thinking what does it mean for organization very soon. But used to frame it.
So if I can make a sort of reflection here. Isn't the point of what you've been doing for the last 20 years, 30 years in Origo is to codify the language used by medical professionals and codify it into a system?
Almost.
Yeah, which means that you have spent quite a lot of time on wrestling with the jävla skitsystem in order to get something that works with the language of medical professionals.
And correct, but not the language of the medical professions, because what we created is the layer behind that. It's building a structure, a meta structure, for structuring definitions. So we don't structure definitions. That's for the one
domain expert
Yeah.
in whatever field we're talking about.
So you're creating the system for the medical professional admins.
No,
No?
no. Say that it's a meta layer that is a system that builds a way of describing human normal knowledge within a executable machine that is a computer. So it's not.
Yeah, but that was what I was aiming at when I said it's a translation layer between the language of the medical professionals, because they try to describe the reality of the human condition in medical terms. And what you're doing is codifying that into machine readable or
You can say that. Yeah, that you can say. Yes, definitely.
But
that's fucking awesome.
It's really cool, right?
If it works.
If it works. But I think why I wanted to come into this topic of organization, and I wanted you guys to talk about this, that I sense between the lines that on this 20-year journey to try to figure this out, there is some sort of fundamental truth about how to build systems that sort of that becomes almost like principle. Let's try if I have understood some of the stuff correctly. So if you want to build systems that really work and helps humans, so to speak, in a way, the way humans think is based on our language. And it's based on our language in the context of how we use that language. So if I'm a doctor, I think in some way because I have a vocabulary. If I learn and knowledge in a sport, I start, So language, knowledge, and intelligence is somewhere interrelated.
Definitely.
Yeah, and what happens now is that a really well-functioning system that augments humans. One understanding I have then is that, well, in order to have meaning in the words, and in order to be able to have meaning in the words that we can make into machine code, it probably needs to stay within a certain bounded context.
Yeah. I mean, you have a structure for how we are talking now. Now we're talking English, or we could talk another language. But you have a structure on how you put together pieces of information into something that our human brain can process. That's the language. And the brilliance of human language is that we don't reinvent English when we figure out how to build a nuclear plant. We just evolve. We utilize everything that we learned.
In English as a vocabulary?
Yeah. And then we just put the new concepts, and we give the new concepts some new names, the terminology, the wording, and then we can use exactly the same way of communicating about a nuclear plant and a football game, or...
Because within the context of building nuclear power plants, the people who are the physicists or the engineers, they have now a bounded context of the nuclear power plant, so the words they use, some are unique, but some are common, but they're now bounded to a meaning of the context that they're in. So when we are saying a certain word, it means the same for them because they know, well, we're building nuclear power plants.
Yeah. And
if you use the same word in a completely other context, it would, it would mean something else.
No, and that's, words. fackspråk in English?
Jargon?
Jargon, yeah.
Fackspråk is
professional
jargon, professional language.
Yeah.
So basically what we are highlighting here is that if I simply follow the logic of how we talk and language and meaning, it has a profound understanding that, well, when we build systems, could we ever build monolithic systems, or do we not always need to have organization, systems, language in some sort of bounded reality?
It depends what you mean by system. I mean, today I think we interpreted the word system within a computer.
Factual language.
Factual language.
That sounds silly, actually. I don't think that's true.
Okay.
Factual language. I never heard that.
Anyway.
He misspelled the Swedish one.
FACK.
Yeah.
that was a good illustration.
It's
But
yeah. No, wait. So system
yeah,
is a concept. That's a trap word.
Yeah. So maybe we should let Mikael talk a little bit about systems, because I think it's a core word here that comes back all the time.
Do we really have time for this?
Yeah, because we go down different rabbit holes, and ultimately, when we've gone down a rabbit hole, how does this impact how we need to understand our organization? Because data and AI, we say, is going to be a data AI software first society, right? Data-driven society, right? We use these words. But if we don't understand the deeper meaning of saying data-driven in terms of, data-driven means typically you kind of need to be in a domain, in a context, and it has implications for how we need to then build our systems and organize our organizations.
Yeah.
Is my simple argument. So I think, yes, let's go down a little bit of a rabbit hole on systems.
It's not a rabbit hole, actually. It connects everything. System it's wide.
Yeah, it's wide.
Anyway,
so, but put the context why it's wide, so we have a definition on it then.
All right. So we have first issue. We talk about nuclear plants and how to solve the problem of a nuclear plant. That means we have to describe the problem. We have to codify it. What is the problem? In order to make it tractable. And then we solve it. All right? So we have to get a common understanding of how to run a nuclear plant. Okay, let's go back to the ant brain. So the ant hill, the ant hive, they have evolved an agricultural system using very minute brains working together. What I'm saying is that the ants have, by evolution, evolved themselves into a dead end because their system of agriculture is efficient given that the conditions, the underlying fundament of their agricultural system, it will work until the environment changes. So what happens? So take climate change. The leaves they're using to feed their mushrooms, the fungi. What?
The ants, right?
What?
You're coming back to the ants for the fungus, or no?
So
for some time now.
Just put some context there.
Yeah. So the environment changes, climate changes. The leaves they use to feed their mushrooms go extinct. Do the ants have any reservoir of different responses? Can they react to this in any meaningful way. When the supply of leaves for their specific mushrooms dwindle, or will they simply just have to die out?
Probably die out.
Yeah, and that is the problem of efficiency, because as soon as you get rid of your ability to think different, to have a sort of a bigger brain to cope with the uncertainties and variations in your environment, you will be screwed when the environment changes. Same goes for okay, I'm not saying that nuclear power plants will suddenly, the conditions for nuclear power plants will not change. I mean, that's physics, and the laws of physics tend not to change.
But you came into, I mean, like you came in from one angle on the rabbit hole of what is systems and definition, but we actually ended up in thinking about a system.
Yeah, it is systems, because we have to codify a system for it to be a system. The system is about how we perceive it, how we codify it, how it actually works. I mean, the map is not the territory. So our description of a system is the map, but the full complexity of the territory we're trying to describe in the map hides a lot more complexity that we're not seeing.
Mm. And so basically when we build now systems, and we basically, the territory, of medical, as an example, is super complex. Mm. And what we're trying to do is codify a map that helps us guide us through this territory as efficient as possible. But of course, whatever we are codifying down on that map is not every single molecule or atom of the territory.
Or every interaction of different molecules.
Yeah, so per default, when we build systems, we will only always deal with a very core snippet of information.
Yeah, we will. But if we just try to extract information from today's systems that are actually built to be communication system for a group of people, then the information lacks a lot of the underlying information. The map doesn't have height curves. It doesn't have the small paths in it. So it's really useless to navigate on. And that's where it comes to the problem for AI, for example, that if you run an AI on information that doesn't really describe the underlying territory of what's supposed to describe, and then you have findings of that information, and the information actually don't reflect the underlying territory, then the analysis will be by default wrong.
But and one way of looking at this then, to solve this, typically you have the territory of a city. Okay, this is the real physical city.
Yep.
But ultimately then, in order to have any useful maps, you will have distinct different maps with a very distinct purpose. You have a map if I want to drive from A to B. You have another map if you want to take the subway from A to B. You have a third map if you want to walk from A to B. You have a fourth map if you want to look at the sewers of the city.
Yeah.
So I think what happens now is that you.
Why would you ever want to look at the sewers of a city?
If you're
is this a weird fetish of yours?
No. Yeah. If you're a sewer swimmer, sewage surfer. Yeah, but the point is this: like, our systems are literally a map of the territory for a very specific purpose, typically.
Yeah. So instead, we should try to see. What is the underlying fundamental of A and the other underlying fundamental of B? And then we can use that understanding to do draw different maps for different people, but the A and B don't change.
Wait, are you talking about personalization of medicine?
That's of course one.
But ultimately, I see how this is actually one of the core, value propositions of Origo, because ultimately, instead of looking at the system and codifying a system that becomes one map that can only be used for one purpose, if I focus on the core objects and the fundamental metadata around the relationships for the different objects, if that underlying layer is always there, I can now query the underlying layer for a map for this purpose or for a map of that purpose. And all of a sudden, instead of building 50 different systems because I need 50 different maps, I ask 50 different questions to the underlying layer.
I will go back to that in this recording and write it down. That was a very good explanation. Thank you.
So, but it's really...
But there's a complexity here. So, and it's at least two-dimensional. First dimension is when it comes to personalization, and that is the situational context of any given sort of object or data point or individual within the system, because they have a personal chemistry, personal biology, and the sort of gut biome and stuff like that differs from individual to individual. So the combinatorics tend to be rather huge. And personalization is about crunching all of the parameters and the permutations. That's one dimension. When it comes to sort of the problem of a system. The other thing is that what if the system we're describing is a 2D projection of a 3D system?
So you're not really, like to depict the reality of the system, or the digital twin, so to speak.
Yeah, is a system as it is codified, is it a digital twin or is it an evil twin?
The tricky point is that if you lose out on the core or very core critical parameters of the reality in your system, the 2D version doesn't show the pitfalls or the or the fire, so to speak, or the swamp, so to speak.
Yeah, but I mean, reality is fairly non-linear in a lot of ways.
But of course, and here we can go all the way back to how do you solve self-driving cars? The real problem is not to have an AI doing the reasoning if I should go left or right or brake. The real AI problem is to have a good representation of the territory. So we have moved the real territory into a vector space, as Elon calls it. Then we can actually quite easily infer reasoning what we should do.
But then you're in map territory rather than territory.
So the whole idea, if I flip this whole conversation back to self-driving cars, is the difference between the territory and the map. And then now for the AI to work in the self-driving car, is ultimately how can I make the best representation of the real world? So it's as with the real world noise, that is the real problem. That the 2D map is dangerous in the 3D world.
I would say it's a bit of a different problem when it comes, for example, for medical information. One of the key issues that we realized that, the information needs to reside around the person that actually has the information. So it needs to be, I need to own my own information, and then I need to share it with other people. And that will sort of, if I can gather all the information around me, collected whenever it could be my step counter in the phone, or it could be some journal text from a physician, or it could be some measurements or lab reports or whatever. If I could harvest all that information, then I have sort of the map, the data map of me. Then if you need to understand me from my data, you can ask my data map the question that you need to ask.
As a physician, as an example.
Yeah, for example. And so when we talk about system today, we talk about a system that has the logic, the storage, and the interface in one, interconnected. That's a system today. But if you extract the data and then you build sort of the logic and the interface differently for different people, then you have the analogy of the different
maps.
Yeah, that goes from A to B, sort of, but have different ways of looking on the path from A to B. So if you collect all the data around you, and then you utilize that data for different purposes, for different people in different circumstances, then you don't have a system like today. You will have a lot of small, back in the 80s and early 90s, specialized systems that does exactly what the organization or the physician or whomever is utilizing that data. They could build, totally personalized systems utilizing my data for a specific reason. But if that data that I have, that data needs to have a lot of more knowledge of how it was created, who created it, why was it created, in what circumstances was it created, what kind of version of the machine that did the sequences of my genome was used. So I need all that contextual information around that data. But if you have that, then you can have a data lake per each person, so to speak.
But the interesting topic here, because what we're talking about now is very much, in my opinion, there are different ways of describing it. But in other terms, how do we decouple data, or not only raw data, but sort of the semantic meaning and the link to data from many different things as a foundational layer, so we then can, for whatever use cases, for whatever needs, we can then use that data to really rapidly create, or really sniper-ish create exactly the relevant user interface and logic to solve a particular task or question.
Yeah, and that's where this meta ontology comes in.
Yeah,
the way to describe an ontology, or a computer ontology anyway, is a way to describe a particular thing or subject or realm or whatever. The way you describe that and what tools, cognitive, rather lingual tools that you have to do that definition, that's what we have been building. And then how you then utilize that, it's up to a specific subject. It could look different. But the reason is to harvest as much surrounding information around each data point so that it will be possible to build what we today think of as systems. specific for different usage of the exact same data. So it's a way of describing. To do that, you need to describe structured human knowledge in a computer, and that's not a way to do that today. And then you need to interlink the data. I mean, I weigh my weight is 80 kilos something. That 80 is just a number. What is kilo? Who is Robin? When did you measure that? How did you measure that? All that information around that figure 80 is relevant if you're going to use that information. And in medical, you usually talk about primary use of data that is within the system that you use it, and then it's secondary use of the data. That's either transferring data from one system to the other, in interoperability, or it's transferring that to a data set for a scientist to do some analysis of the data. But the way we need to think is that all use of data is secondary. Then you leave the paradigm of the 80s system construction behind.
Yeah, and all of a sudden now, let's move this now a little bit into organization, because what we are now
No.
Not yet.
No, because what Robin just said was profound.
I know it is, because it is the decoupling of the meta. It's not as easy to describe it as a decoupled data layer, because it's the meta. This is the data, the meta. Give me another beer. Give me some stronger.
No, seriously.
I dare you to say meta once again.
Robin said the word meta-ontology.
Meta-ontology, thank you. That's what I was
Yes.
looking for.
That is just a description of epistemology.
Let's go this way. What is epistemology?
Epistemology is the means we have at our disposal to learn about ontology. Because ontology is a description of the world, a system, if you so will, a codification of reality. Epistemology is how we arrive at those systems. How can we learn about them? How can we validate them?
So, then continue the
trajectory here is that if we're going to leave the 80s, actually go into the future, data is always secondary, because we have to look at not what the data can tell us, but what data we need to answer our questions.
So we need the core data in one way. What is secondary and primary here? But what you're saying is that if we have
no, what I'm saying is that if you use the data you have, you limit yourself in terms of what questions you can answer.
So what you're saying is that actually, when you build system, of course, start with what is the problem, what are you trying to solve?
Yeah, what is the question you want to ask?
Or get an answer to.
Yeah.
This is the core, why we need systems at all, right? Or why we need support. Then comes the core top.
No, wait. That's the problem of a system, because a system exists to serve a specific purpose.
Yeah.
Okay, yeah.
That might not be the answers you're looking for. These are not the droids you're looking for.
Okay, so what are we saying here? You lost me a little bit on the end there, Mikael.
No. Any system is a product of its time.
Yes, when it was built and for what purpose?
Exactly. So, we are on an evolutionary path. Things change. New questions arise. and we need new answers to those questions. An old system has to be repurposed in order to serve our current needs.
This is really interesting. I think you're into some core thinking here.
So what we are saying is that because ultimately, on LinkedIn, someone said it really good. What's the problem? Why we're not accelerating, or why we are not making smarter systems? Is basically, it's very easy that we are dogmatically trying to solve old problems.
Yeah,
we are not really first principles rethinking the problem and understanding what is the real new problem we need to solve.
Yeah.
Is that what we're talking about?
Yeah, definitely. And that goes back to, that is really what I was trying to say when I said that what if the system is a 2D projection of a 3D system? Is that the system as it exists was a snapshot in time of an evolving system, or an evolving reality. So what it was does not really map to what it is today, or it may not serve the needs of today.
And the core topic becomes then, we are throwing a lot of money to try to solve an 80s problem, instead of reimagining the process. And I think this is what when we a little bit casually sometimes say, data first or AI first, it really means if you truly understand the power of data, like we're discussing now, you can completely reimagine how you have a meta-ontology and how you build very small, very fit-for-purpose apps to solve very specific needs, which gives you a completely different system architecture, and I would argue a very different organization, by the way.
Yeah.
Because you will now have an organization which are focused on the meta-ontology and whatever platform that is all about. And then you will have, in my opinion, the applications we are building on top. We are back to the 80s programmer sitting next to the physician.
Right. Yeah.
So we are coming to a topic where you need to have an infra or fundamental layer that someone is taking care of. And now we're talking about meta-ontology, and you can take it infra, self-service, you can talk many different topics. But in the end, when our processes are bounded in ones and zeros, we need to have a cross-disciplinary team in every core process we are dealing with. If you're a physician, if you're a doctor, and then you can spit out your applications as you go.
Yeah.
So the future organization of, forget about IT supply and IT demand. You will have tech people working on the logic over here, and you will have meta-ontology or core platform infra people serving it.
Yeah.
I think this is obvious that organization and how we look at tech roles goes in this direction.
Yeah. It's interesting because when you rephrase things, it sounds different to me, and I could just say yes. So
and then we come back to the issue of communication.
Yeah,
but it wasn't that nice. We could make it back into organization, that the programmer sits. You said it. The programmer sits with the physician, but not to do the whole stack, of course.
No.
If we're going to talk about efficiency and effectiveness, the program is sitting beside the physician and doing a bespoke system for him or her to solve his or her problem. That is very good for the individual physician, but it's fucking expensive if you're going to do that for a hospital.
It depends on how complicated the programming, and I do the quotes, the programming, because for everything you do, you have a description of what you do. You decide. I mean, you have this is how we work. This is how we should work. This is what we look at, and this is the parameters that we take in considerations, and for this parameters, when it's between 80 and 20, and it's between 25 and 80, it has some meaning.
So you're saying there's a limited variation that the programmer needs to be able to deal with?
Yeah, because if you take that into the knowledge part of this, I mean...
Yeah, let's go to knowledge now.
Yeah,
this
because
is a logical step.
If you capture the knowledge based on the meta-ontology within an ontology where you describe what you're doing and how you evaluate. I say that, okay, if I have a pulse of 120 right now, it probably is not that good. Then something should happen. That's how we think. And that's how medical guidelines are evolving. I mean, if you see that one person has below this but above that, you should put in this medication, or that person should start to walk some.
But you can argue then.
So that's algorithms.
This is the business rules, algorithms, or rules in relation to a very clear context.
Yeah.
Now, of course, the tricky point now becomes, how narrow do we make a domain? Do we have one programmer? Is it a domain of one person? To be argued, maybe it's a domain of a department. Maybe it could be quite logical if in a hospital you have your medical departments, so to speak.
I think you like the analogy of the onion, don't you, Henrik?
Yeah, I like to peel onions. I've done that a lot with you. Let's peel the onion on this one.
So
I can't remember. I like onions.
So, I mean, the fundaments of something is usually common. And if you have that defined together, then you might, in this particular setting, you change one of 5 parameters. And that's fine. Then you have the 4 other parameters already defined, and they're equal to the other one who are doing this. And you come into the third place and you add a 6th parameter. And that's fine. You have at least 4 common parameters, but one needs to tweak the 5th and one needs to add the 6th. That's how things evolves. But if you could track that, you could see that all these 3 are common within 4 parameters, and they're narrow, so depending on what kind of analysis, what you need to utilize the data for, you could probably use all that data for some high-level analysis, but you could only use one of the 3 for a deep dive analysis. But that's okay.
But the way I interpret what we're talking about now, that typically now, let's go back into organization. We will then typically, the meta-ontology, which is, and the data, underlying data, this we have talked about that. Now we're into domain. And now typically, the logic for organizing or framing what's an organization, from a data point of view, okay, I don't care about if it's many people, but here we need a programmer with a very, very bounded, concrete context. Will this not be the way we organize domains is in relation to what is a very concrete value creation we are trying to do. So
yes, but that's how we do it.
And this is how
even
work
without computers.
Even without computers, the value chain of a hospital or the value chain of any company we have a clear contribution in our organization. That's why we are paid our salaries, so to speak, to provide a task that serves a purpose. Ideally, right? Otherwise, we wouldn't do it. We wouldn't have the organization. So typically here, when you start looking at this organization from a data point of view, we can argue, well, instead of talking about processes that we are solving here, if we take a product-centric mindset, that this is an offering, our job is to provide this task. This is our service. So I'm saying it a little bit like this because then we can start thinking about algorithms. We can start thinking about different things as features of doing a specific task. Now, when we say process-oriented, we kind of start thinking analog. If I'd go systems and I say, what's the system view of performing this task? What's the app view? What's the experience for the user? What's the experience for the doctor? What's the experience this? Here now becomes a very simple understanding of the different core offerings that makes up the complete ecosystem of offerings in a hospital or whatever. And if I use follow, what's the core contribution and offering of this department? Is that different to that one? Well, that is another domain. If this is exactly the same, well, it's payroll. It's all payroll. It doesn't matter if it's all the different things. It's payroll for the whole company. Well, that's one product. You see what I mean? Like, so to start cutting the slide, what is the map here of the sort of the algorithm and data organization, so to speak?
I would say that from our perspective, we just decouple one of your words, data from the system. Yes. And you do that decoupling with as much contextual and surrounding information, knowledge around that data. And once that is decoupled, you can utilize that data in many different ways, depending on your needs.
Exactly.
And the utilization of the data is when you start to think a system.
Exactly. And so we're on the same page. But so what I was exploring now, if we have the ontology...
There's several pages here.
If we have the meta-ontology on...
No, wait. So you go back to an earlier discussion which said that if you try to solve problems that your data has answers to, that's one thing. If you pose new questions you may not have data for, but are the relevant questions, that's another thing. So you need to decouple the data, just as Robin says, from the system, because you can repurpose data. You can see it in a new light. You can reframe it. And now we go back to sort of the topic of this entire podcast, which is the meaning of data.
And organization, actually trying to get to organization as well.
Yeah. And system is organization. I mean, it's the same thing.
Is it? I mean, like, you said that very fast. System and organization is the same thing. What do you mean?
In a narrow sense, any system is an organization because that's how you sort of stipulate the relations between entities.
So you're organizing data or different entities in order to perform a task.
Yeah.
Okay.
But then you have second order organizational perspectives if you think about changing environments, because then you need to have an organizational system that can detect, identify and respond to environmental changes. Is that an organization or is that change?
I mean,
depends on how you see it.
I think this now we're getting tricky here to follow, right? Because we are, I mean, like some way, when we say organization, in my head, when I'm saying an organization, I'm talking about how have we decided to chop up different roles and people in teams in order to perform tasks efficiently as possible of a large enterprise like a hospital. So for me, organization is to one degree, how do we organize work?
People.
How do we organize work, and ultimately how we do then organize people in order to perform work efficiently. So this is organization in one way, right?
Yeah, that's organizational in the operative sense. You create an operation.
Yes, exactly. Now, you were now talking about organization deeper or from a slightly different angle. Or
Yeah.
how do they relate?
The second order of organization is, first order is, how do you chunk the operation? You have inputs and you want to achieve outputs. And you have to chunk the processes. You have to define the processes to get from input to output. That's the operation, the operative perspective. That's a system, that's an organization. Second order organization deals with supervision. Because you have sort of, if the demand wanes and you have new target groups that occur, your market analysis evolves and you identify...
Your patient groups goes up and down.
Yeah, definitely. And you identify new sort of nuances of medical conditions or consumer behavior, and you have to respond. You can turn the brakes or the accelerator on your
So
operation.
second order organization is
Supervision
in order to basically optimize and steer in relation to the operations underlying,
Yeah.
simply in order to adapt most efficiently to this surrounding context.
So stimulus response.
Okay.
Basic cybernetics of a single cell organism.
Okay, so now cybernetics. Very quickly, what is cybernetics?
It's the control system, the supervision. Or rather, the cybernetics domain or the discipline evolved from the control system of organisms.
The control system of organisms, cybernetics as an academic field in the 40s, I guess you said.
Yeah.
Something like that, which is ultimately about second order.
Yeah, funny thing about cybernetics is basically the work of one individual. A guy probably named Stafford Beer. I know it's weird. He was named Stafford Beer. Stafford in his first name and Beer second name. Okay, that's trivia.
This is trivia.
Yeah, cybernetics is sort of the logical formulation of control systems, feedback loops in systems, and how to express that logically, mathematically. So, and I think it helps to understand the origins of cybernetics when you think about stimulus response for single-cell organisms. I mean,
say that slowly.
The stimulus response systems of single-cell organisms.
Which means?
I mean, you have signals for food, you have signals for reproduction. Well, no, single-cell organisms reproduce asexually, so it's cell division, so no sexual reproduction. So you have basically have food and you have threats, and you have supervisory systems that identifies food or threats. Food, get closer. Threat, get away. Cybernetics.
That is core cybernetics of a single microbe.
Yeah.
And now of course cybernetics. This is the single agent. We are now talking about different types of single, multi-agent, or complex systems and stuff like that.
Could you call that meta organization then? I mean, basic for organization. Food or fly?
Maybe.
Actually, we've already muddied the waters because of talking about cybernetics as second order organization, supervisory systems. But then you have second order cybernetics.
Just to make it more fun, yeah.
Yeah, this makes it more fun, which is the existential systems. And now we're talking about rewriting the supervisory systems, reclassifying stuff. Is this food? Is this a threat? So we're changing the entire nature. We're reframing the nature of our single-cell organisms by defining, this is food. Go for it. And Yeah, that's now a threat. Get away from it.
All right. So let's take this down to earth, and we are talking about.
We're talking about single-cell organism. How more down to earth can we get?
But let's take it down to how we understand business, right? So we set up a process, and we have a policy that sets up a process in order to achieve a certain goal. So when we're talking about that policy, we are supervising that policy. So now we're talking about second order cybernetics. No.
Second order organization.
Second order organization.
And that is cybernetics.
That is cybernetics. Now the next level of this, which is second order cybernetics.
And third order organization.
And third order organization is basically what goes on top of the policy.
Actually, scrap that sort of description, because we can go straight to cybernetics, where you have the operative system, you have the supervisory system, and you have the existential system.
Yeah, and let's talk about this in plain non-cybernetic lingo, so people can link to this, because I think it's you have a simple process. You don't have normal people lingo for this, because normal language doesn't operate on this level.
Could you just repeat those three levels again?
The operative level, the supervisory level, which means just to sort of deal with the variations in the operative layer and the demand system, so to speak, or variations in your logistics. So if the logistics go this way or that way, you can supervise the operation. And
third,
and then you have the existential system, which rewrites the supervisory and the operative systems to say, no, we're not going to do that anymore. We're going to do this instead.
Let me just rephrase this, that we have strategy, tactics, middle management, and operations. I think it's that simple to some degree, because
it's a brute force.
Sorry, that's actually a matrix.
No, maybe it's a matrix, but I think when we're talking about cybernetics, and we never talked about it before, and we're learning about it, I want to make an analogy or to a different way of thinking, and I think it's simply put: we have an operations that is doing something. We have a supervision of that operation in order to.
And here's the problem with language. You're trying to combine two things that are actually orthogonal.
Orthogonal?
They're right angles to each other.
Okay. Which means?
Well, you have an x-axis and a y-axis.
So they go on the one is on the either one axis and one
so
is...
the cybernetic levels does not correspond. They're not the same as the operative, tactical, and strategic distinction, because that's on another axis.
Okay.
So when you conflate those two, you
muddle the water.
You go back to the 20th century, because then you have the sort of standard, the executive, managerial, and operative pyramid of the 1900s. And we're trying to move away from that.
Okay, but I think because to move away from that, I think to understand these differences and to find words for someone who has not been into cybernetics.
Yeah, but I think that's a problem, because we're hitting the boundaries of language here.
Interesting. We are actually.
Yeah,
I'm trying to push you into a language that I understand, and actually I'm then muddling the waters.
Yeah, definitely, because I mean, it's not a bad thing. It's not a bad thing at all, because we have to try to make sense of reality. I mean, we're trying, and that's why new words come into existence, because we have new ideas that don't really fit with our description, with the system.
With the current system.
Yeah, exactly. So we're trying to go beyond the system, and the only words we can use to go beyond the system are words within the system. So we have to combine the words of the system that are in contrast to each other to say new things that are beyond the system.
Yeah, it becomes words and semantics now. For me, I'm sort of, now we're on the border where, now it's tough to follow. It's really tough. What do you say?
I say that this makes perfectly sense.
You can follow.
Yeah, I think so,
I can't
actually. Because
Robin and I, we have the same disease.
probably disease with no name. I especially when you talk about the problem with utilizing language, it is a problem, because if you have a set of knowledge concepts that depict something that you try to communicate, and if the receiver of that communication is misinterpret some of that of those concepts, then you have a mental breakdown.
Yeah.
You don't understand. And when you don't understand, you try, because we are human beings, and this is where the human being come into play, because then you really try, because you want to be nice to the one sitting beside you. So you try to say that, yeah, I understand.
We don't understand shit.
No. And yeah, good, thanks. Yeah, perfect. And keeps on talking, and you say, oh yeah.
But it doesn't move us forward.
No. So if we don't, and I think that this is, if we are going now, I think we passed 2 hour.
No, not yet. Not almost, but we can stay on. It depends on us.
It's 4 minutes.
What?
4 minutes still.
4 minutes left,
Okay.
and then we can go do another 10, 15.
Okay, because going back to understanding each other, we need to move slow and to, okay, you say this, I don't understand, please explain. And that could take some time. But usually today, especially today, we don't have that time because we are moving forward. We can't sit and dig in that whatever cybernetics who someone said some ages ago. We're moving forward. It's a trajectory to the future. But then you misses the whole point, because our life is actually circular. We are mud, and then we live, and then we become mud. And that goes for every living existence. Everything is circular. And the organizational structure of humanity has been far more advanced, probably in Egypt or in some other ancient culture. Nothing is really new. But we have this notion of moving forward, so we don't have the time to reflect on what the other person actually means. And then we miss it, and then we actually move backwards. That's
At
the
the same time,
philosophy of...
At the same time, a circular motion taken through time is a spiral.
Yeah. It could be.
Yeah.
But could it be a spiral going in the other direction too?
Yeah, that would be bad.
Yeah.
But let me...
And if we don't have the time to understand and to... When we discuss, for example, say AI, artificial intelligence, what do we mean by artificial? Yeah, we can understand that. But what do we mean by intelligence?
Yeah, this is the core, discussion when we have tried to define it and discuss the definition of it. Is like, how do you define intelligence? What's the difference between learning, knowledge, etc., etc.
But
I would really need a whiteboard right now.
Yeah, are we then moving forward as a society, as a human race, or guardians of this poor planet?
I'm an optimist. We are moving forward, but I'm worrying about the shape of the curve forward.
Okay.
Yes, let's go here. Because I think we have now explored from data and these depths We have come into different topics, some learnings on how to organize. Then a lot of rabbit holes around cybernetics and all that.
Yeah.
It's fun. And ultimately, I mean, like, I think there are several insights we didn't get to here, Mikael, that we sort of, when we start looking at these topics, it leads us down to deal with organization in different ways, or it leads us down to different ways. But maybe we're not going to get all the way into that. But I think to start looking at these different topics from different perspectives, I think that's the other angle. If we are only sort of working with AI or data as engineers, we are not evolving, because if we are not broadening our inputs and concepts, we're not gonna crack the next code, because we are thinking within the box. We need to have outside inspiration. I think that's the other game here. I want to understand the other person. This cybernetics thing, what is that? How does that relate to this? Now, 1 + 1, intersectional innovation, I can figure out something new I didn't see before. So the tricky point with moving fast forward, it doesn't really happen if we are stuck inside our current system and with our dogmatic groupthink thoughts.
But what is forward?
I think actually you have, if you want to take it down to microbe level, the data we have and the data we need. Because if you're working with the data you have, you're not moving forward. Mm. If you start pondering, what data do we need? Then you're moving forward.
Yeah. But what are we moving forward to? I mean, like, one argument could be...
Who cares, as long as we're moving forward, right?
But I think the core goal...
I would beg to differ.
We need to be smarter to cope with the planet. I think that's a good goal.
Yeah. And how do we do that? Well, we organize ourselves in better ways. We utilize better tools. And when it comes to healthcare, we minimize the resources to keep the ones living healthy. That's a good thing. And that could be sensed forward. But is it forward from going from where to where? That's not really, because when it comes to the ecosystem, we need to go backward. I mean, we need to have more species again, instead of killing out species that we now really realize that are really fundamental part of keeping us alive on the planet. We need to recreate, I mean, we recreate våtmarker. What is that?
Marshlands.
Yeah, marshlands.
Wetlands.
Wetlands. And it's really interesting because, I mean, coming back to communication, they did a survey about wetlands or marshlands on Swedish farmers who have own lands, and why should you recreate marshland on your property? The first thing most people mentioned was that it was a good ice skating place in the winter. That was the number one positive thing for the farmer. And that had a lot of positive things for the ecosystem. But this is really, I mean, organization, communication, is that forward? Yes, because we didn't know that farmers like to have an ice skating place for their children close by. But that was the first thing that they thought of. What was the good thing about recreating?
Now we're coming to another favorite topic of mine, value creation.
Yeah.
Because what you're saying here is that if you sell the creation of wetlands as new ice skating areas. You speak to short-term interests, immediate interests of the population, but it allows us to save the planet.
Ingenious.
Yeah.
And isn't that part of the topic here is instead of asking or consulting the data we have, we should think about what data we need.
Exactly.
And what data we need is not the real topic, but the real topic is what is the problem worth solving, what is the value creation worth doing, and ultimately circling all the way back to humans and how we organize. We need to organize to ask the right questions, to solve the right problems.
And then we're in the existential systems of cybernetics.
And this is then what I was trying to understand, that if, I was wrongly then flipping it, that you have an operation, you're supervising this, but then you need to question, are we even dealing with the right, are we selling the right product? Are we doing the right service?
Yeah.
Or existentially, should we do something else?
So take this example. I'm just freebasing. A municipality says that we need an arena for hockey. Yep. Because if we have an arena for hockey, people would like to stay in our municipality and keep working there. But instead, it might be that if we have a lot of marshlands where we can skate in the winter, it would be much better. So then what is progress? Is progress building this big arena? It takes a lot of material and it costs a lot of energy. Or is it recreating marshland that actually helps the ecosystem? What is progress?
And then progress, then connecting it with value creation. What is value? We can talk about value in monetary sense, but of course now, in this day and age, we need to talk about dimensions of value far beyond money. Because we have values.
Money is just a trading for.
This is what I mean, right? So we sometimes when our value creation, we need to understand the value. What's the problem we're solving, and then immediately people think about the business case. But ultimately, to organize around value creation starts with ultimately then understanding what is value and why is, and what types of values should we strive for, or do we not, what problems are worth solving. And then the climate crisis, of course, is, I don't know if it's even, of course we need to maybe flip it into a monetary topic in order to make this, to drive the total global economy needs to get behind the cause, so to speak. But the real problem is, the real value creation is to save the planet, of course.
Yeah, and for all living species to have a good place to be in.
But if I know,
hey, hold on.
And is that progress? It just
exactly, because in terms of progress, if we're talking about creating a business, we have Ford, because when you market analysis and you want to sort of create the first car, what do people actually want? Yeah, they want horses that don't crap that much and goes faster. All right.
That's the old classic example.
Yeah, exactly. And then you have, I think it was Steve Jobs actually, talking about you shouldn't give people what they want. You should extrapolate into what do people need. So you place yourself ahead of the curve and give them stuff they didn't know they wanted or needed. And then you have progress, which is on another dimension in terms of giving people stuff they didn't want that also lets us progress on sort of the idealistic or humanistic or world-saving tendencies that people have.
But here now, if we bring this back to organization, how do we organize? For me, we are now moving into, if I look at the organizations today, and if I look at this sort of organizational template or ideology that we have had for the last, 70 years, we chase economies of scale. We are trying to have efficiency. We have two mantras. We have cut costs, efficiency, or maybe growth, right? But ultimately here, what you are saying ties back into, we need another way of understanding to reimagining how things are done, to reimagining which question or problems to solve. Now we need another type of organization which is not sort of stale and built to be more and more efficient on the same thing, but ultimately needs to be really, really good at asking the right questions. What is really worth solving? What is the, you can do that on a strategic level, for extensionally for the whole business or organization, but you can also do it on business unit or process level. Is this really the best way of doing things?
I think that we need to go back to both. Economies of scale has really, Moore's law, part of economies of scale. You put all knowledge around the world into making the computer faster, smaller, more energy efficient, and the explosion of the processor within a computer is totally mind-blowing. That's a good thing, of course, because we want faster computers. But if that's the only goal, then we're into the slippery slope that we are now. If we could combine that with the more overarching problem solving, handling the earth, that is the climate crisis and the ecosystem. If we could combine those, but today we have been stuck, as we have been with SQL and the paradigm of computer system building. We need paradigm shift, but we don't need to scrap everything that we learned. So economies of scales are good, but if you combine, I read your article, if you combine the economies of scale with economies of relearning, that is actually an ecological way of thinking.
Exactly.
Reuse.
Harvest and reuse.
Yeah. But today, when we come to ideologies, we have clashing ideologies. We think that one thing should be, everyone should be, it's an individual's society, and when all individuals are trying to do the best for themselves, it will be combined to the best of humanity. No, it doesn't. Or you have the other way around. If everyone is following the same 5-year plan in a Sovchoz in the USSR, everything will be perfect. No, it will not be. So how do we combine these old way of thinking into new way of thinking without having this? What am I? Am I an libertarian? In some sense, yes. Am I a socialist? In some sense, yes. Am I a conservative? Definitely. So what am I? You can't describe me today. And I guess you can't describe most people on Earth today utilizing those old paradigms.
Systems.
Yeah. So we need to start to together rethink systems. What we've done with the Origo program, we started to rethink one small system that has to be around data. But that will not be enough.
No, and this is basically, I think, the linkage between the fundamental topic is rethinking, first principle rethinking. We started the conversation with data. We move a little bit into organization, but we also understand this as we need to find new words, maybe learn from cybernetics, in order to fundamentally rethink.
What do you mean, maybe?
No, of course. We need to look at all the different aspects we can in order to form an ideology, to find, to make a new system, or or actually a completely different system that is ever adapting.
Yeah.
Rather than having a system that drives efficiency in a stale, certain frame, we need to have data, we need to have systems, we need organization that can cope with always adapting and adjusting their purpose.
So for example, take a limited company, ett aktiebolag.
AB, yeah.
Yeah. It says that its sole purpose is to generate money for the shareholder. That is written in law.
And isn't that a noble goal?
Yeah, it actually is, because it's measurable, and you can say that this company is not performing, so they shouldn't keep on doing what they're doing because they're wasting money instead of making some good of it from a market perspective. That's a good thing. But then you have the notion of the society that sets the frame for this money-making machines. And you have two different things trying to compete. Instead, I think that we should start to look for a system where you could combine those things. When you see that, okay, we don't know how to solve this problem. That's a market problem. Good. But in this case, we do know how to solve the problem. Then it's not the market problem. I mean, take school example in Sweden. It has never been, and it's not in the rest of the world, a market problem. It can't be, because it's not the market. What is what are the products you're selling? Is it the children? Is that the product? Or is it the children's grades that is the product that the parents buy? So, I mean, we really need to step back now and start to reframe all the things that we have taken for granted until now, and really rethink how to organize, how to structure, how to set the new playground for how to interact, and then we will have completely different organizations.
I really subscribe to this, that you need to,
Hold on. Because this way to do this, I mean, we do have people who are idealistic and want to build a better world. And then you have people who don't really care or are apathetic or have other focuses. So, which means that it's about legislative action to create new metrics, and then becomes politics.
Yeah, most things are politics.
Yeah, definitely.
But
or resides from politics.
But I think the core insight here is that we can follow what we have talked about data. We can look at Moore's law, into Metcalfe's law, into Kurzweil's law of accelerating returns, and it's super clear. Technological innovation is exponentially accelerating. So, whatever we are doing today will change in better ways to do it tomorrow. And actually...
Or worth.
Yeah, but ultimately what I'm trying to say is that we are talking about the fourth industrial revolution, and we are talking about like this. And I argue, and when we have talked about this, Mikael, actually it's almost meaningless to talk about revolutions like that when the pace is so high, so the steps of evolution is constant. We can't measure anymore in hundreds of years, and we can see here was the steam engine, and now we had the electricity and stuff, or whatever. Now basically there's abundance of technological innovation that could improve the way we do things, but we have simply not been able to capitalize on them because we've been so stuck in the old ways we've been doing things. So so technology innovation becomes now not the technology problem; it's an organizational or learning to adapt and learning to use problem.
Yeah, organizational in the way that we as a species on this planet need to interact to do good things for each other.
Interact to do good things to each other. If we want to do more
and
efficient.
The rest of the planet.
Yeah, and if that is then...
Because we are needed.
We need it. We need to be better goals. But the argument is that even today, we could do much better and get more out of resources, be more efficient, all the way down to administrative systems. Because we haven't adopted a new paradigm of organizing that is learning and adapting. We are trying to solve it in the old way, in a very, we are stuck in the same problem for 20, 30 years, if I look at administrative systems as an example. And sometimes, well, it's not probably wrong with the data. It's probably wrong is how we tackle the problem, how we've organized around this, and how we're using the tech.
Yeah.
So here, I think this is where the whole article comes back in. How do we set ourselves up for adaptability? How do we set ourselves up for innovation? How do we organize so we learn and harvest? How do we go from a human capital learning to organizational capital? So someone is really good at something in one part of the organization. How can we harvest that at scale? We are not organized to do that.
No, but if you take the famous examples of, say, Amazon.
Yep.
They reinvented themselves.
Yep.
So they were really inventive as a company. But what did that create for society? I mean, you have these fairly ugly working conditions for the people that works for Amazon. Is that progression? I mean, Amazon has been really innovative.
But is it progression?
But is that progression? Is it a good thing? Take Facebook. I mean, you had the idea that you could share information with your peers on the university. Yeah, it was interesting. But what did happen then? They got a lot of talented people building a multi-communication channel for the full globe. But what was that used for? And what was the business model? The selling the information of the people, what did that create? It created Trump, it created Brexit, it probably created probably part of the invasion of Ukraine. I mean, so when you have progress, a new, perfectly more efficient way of organizing a business that is just driven by whatever you should have on each quarter in the quarterly report, is that progression. It's really impressive technology. Both Facebook and Amazon has created a lot of impressive technology, but has it helped humanity?
Because what you're saying now, if I'm actually, you're adding a dimension. We need systems or ways of organizing that is helping us innovate, learn and adapt and all that. But there is a huge missing chapter in that article, and that is for good or for progression.
Yeah.
So we need to be good at this, but we need to divert our focus, what we are good at, to solve the problems we're solving.
Yeah.
And those problems we're solving now are and what is value and value creation needs to be expanded way beyond the traditional monetary KPIs. You know, you can be successful and all that, but there needs to be another dimension in why we are solving things the way we do it. To talk the difference between successful or innovation and real progression for mankind.
Yeah, actually, now we circle back to the problem of ethical AI.
Maybe we can go there in a couple of minutes, and then we're gonna.
No, this is actually interesting, because can we raise a new population of AI that are better moral philosophers than we are?
If you ask Anders, he would say yes, most likely, because he would
and
say.
I would agree.
He would say that we can talk about AI is biased sometimes, but it's because humans are biased.
Exactly.
And basically, if we are coming together as a collective of researchers, and we are having a good view of this, it could be done. The problem with ethics, of course, is what is ethical is highly connected to culture and values in a certain context. So ethics is very difficult because it's bounded by culture, it's bounded by religion, it's bounded by region, it's bounded by language.
Bollocks.
You don't think so?
No, this goes back to what Robin says about systems. Is that so? A system is a solution to any given problem, but the problem space is limited because the variation is down to a couple of different variables, which means if you can capture that complexity, you can have a fairly good model of reality.
Okay.
Which means that quite a lot of human moral philosophy goes back to a handful of specific questions or problems or dichotomies. And if we take the problem of immigration, is that usually it's when people come to a new country, it takes 3 generations for them to assimilate or become naturalized. So we are the first generation raising a generation of AI, and we need to build them. We need to build these AI to raise new AIs.
And then
to be moral philosophers.
Do we need to have, before we take that step, can we go in this direction before with narrow AI? Or is this such a philosophical topic so it requires general AI? Can we think in those, can we go in this trajectory with narrow AI? Or is this purely a philosophical conversation that hinges on?
No, I think moral philosophy is simple. Well, no, it's not simple. It's of course it's complex, but it's not a complex problem. It's not NP complete. You have sort of a nonlinear system, but it's a limited number of variables. I think we can deal with it.
So you think you can deal with ethics mathematically?
Yeah.
I like that idea. That's cool. How?
I mean, and I think we have to go there because I did paint a picture of people as stupid and AI being our nurses.
And which would upset a lot of people, by the way.
Yeah. But I think we have the opportunity to raise a new form of entities that can actually surpass us. And now I really showed my techno-optimist.
Yeah.
Are you let's leave it at that. Are we techno-optimists? I think it is time to round it off. Are we techno-optimists? You are clearly.
Yes.
Anders is. I would say. I would say like this: we really need to become. I would steal your quote from now, Robin. We really need to be a hell of a lot smarter to cope with the complexity of fixing the planet for once, and we need to be a hell of a lot smarter to build systems and organizations and companies that is progressing for the good, not just making money, but that we could define as ethical, valuable progress for humankind. And I don't think humans can do that without support of technology.
Here.
So then we need to be technology optimists in order to get us out of the hole.
Or we need to be optimistic that we could harness the usage of technology in a good way. And I think that's a bit of a difference from technological optimism, because you depict the AI nurse of humanity.
Exactly.
And I would say, I don't believe that.
Okay, so we take the antithesis of that, which is the population ecological view of that, which is that if we get killed by the robot uprising, we deserve it.
Yeah, probably.
Yeah.
Or something, none of those will happen, but we will. I mean, like there isn't there a third way here, which I think
Definitely, but I mean,
augmented intelligence.
I think so we have
we
one.
just
We
painted
have
the boundaries of either direction.
Yeah.
Either we get killed by the AI we created, and then we deserve it, or we create our own caretakers.
yes, or
Which is sort of the lotus eater dream.
or then we have augmented intelligence.
Yeah.
And that way humanity evolves.
Yeah.
The third version
Together with
the third version is
technology.
humanity evolves together with AI, but they're not nursing us.
No, it's organizational intelligence. No, it's not organizational intelligence. It is synergistic intelligence, because you have meatware intelligence.
Meatware, meat, brain.
Okay.
Meatware.
Sorry.
And hardware intelligence working together.
And we
Meatware,
get the symbiosis of the organization as an algorithm of a neural network of AIs and human brain power. Yeah. Hallelujah.
Yeah.
Well, not hallelujah. It's just going to raise new problems, of course. But I mean, that's the nature of evolution. We get new problems.
But what is evolution? That comes back. I mean,
Evolution is just solving one problem and getting a new one.
okay, then evolution is not evoluting. It's just
Progressive.
circular. Yeah, but if you go the full circle, then you have the same problem and you solve it all over again.
No, it's a spiral. New problems.
Okay. And is it an upward or a downward spiral?
Hopefully not.
That's for the moral philosophers of the future to decide.
The moral AI philosopher for the future.
Yeah.
Oh,
Guys, I think we need to get
Actually-
into the after work.
And the funny thing is that Asimov actually already did this mental exercise, because one of his short stories is robots documenting the fall of humanity. And thinking about, why did humans go extinct?
Asimov as the person who wrote the famous robot laws. Right?
Yeah. And Foundation Trilogy and a lot of stuff.
A lot of other stuff.
I realize now it might have not been Asimov, but I think it is Asimov.
Anyway, I think we're going to put the lid on this fantastic podcast. I'm not sure which direction. We talked about organization. We talked about
A lot of stuff.
a lot of stuff. We started in data.
Hey, I have an idea. What if we just hijack this podcast and continue with the three of us forever?
Forever. You think that this is so much fun?
Yeah.
We had so much fun. I hope the listeners had equal fun. Robin,
thank you.
thank you for having you here. Super fun. Mikael, always a pleasure. And I love this conversation. I hope.
Fuck it. We'll be back next week.
Thank you very much, everyone. Take care.
Thank you.
Bye-bye.
Aww.